Welcome to Math 105, Chapter 7.2, where we talk about relative frequency. So now that we understand experiments and events, we're going to look at what happens when an experiment is actually performed. So when it's actually performed, it has the word relative in it, which we're going to take a look at what it's going to look like when it's not um, an actual experiment. Instead, it's just going to be modeled for us. So for these ones, we're just going to actually perform them. So it says when an experiment is performed a number of times, the relative frequency or estimated probability of an event E is the fraction of times that the event occurs. Now that has the equation P of E. So that P is always going to say probability. So this is the probability of the event. Whatever event we're talking about is equal to FR of E, which is the frequency of the event, how many times the event occurred, over N, the total number of trials. How many times did you actually perform this event? So this is the frequency. Let's say we're flipping a coin. Actually, I'll just do that the next one. So for example, let's say this is a coin toss. We did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We flipped this coin 10 times and we observed that perhaps this one, these little pink circles, are the event that we're hoping for, that a head came up. So we're counting the number of heads, which in our case, heads came up 4 out of the total 10 times for about 40% of the time. Now the collection of the estimated probabilities of all the outcomes is called the relative frequency distribution, or the estimated probability distribution. Now, what you're going to be doing a lot of is figuring out all of the probabilities for each event. We just did one where we had heads, then we could do one where we had tails, and maybe on this next experiment, we're going to roll a dice. So in our experiment, now, if you have a dice, please pause the video and go get it. If you are taking it in person, don't worry about it. I have all of those dice. Otherwise, we're going to be using that simulator. So it says, roll your dice 10 times and record the outcome below. So we're going to go over to, where's the little Safari button? Let's see, they're right here. Nope, that's not it. Oh, right there. All right, so we have 2 dice here. I only need 1, so I'm going to put that down to 1. And you're just going to roll this 10 times. We got 4, 5, 6, 4, 2, 4, 5, 6, 4, 2, 4, 5, 6, 4, 2. Let's see what else that comes up. 3, 1, 4, 2. 3, 1, 4, 2. 3, 1, 4, 2, and I'm just going to put a random 6. Okay, so you've performed your own experiment where you're just rolling your dice 10 times. Now what we're going to do is calculate the relative frequency, the set of all outcomes for our dice. Now, because we're only having one dice go at a time, we're just going to do the numbers from 1 through 6, just a regular dice. So if our normal outcomes is from 1 to 6, right? We're going to look up here sorry, that is my dog in the background. We're going to look up here to determine, well, how many times did that number come up? So in this case, my 1 came up 1 out of how many times? This is 1 out of 10. Actually, so sorry, getting ahead of myself. 1 time, right? So the relative frequency we said is 1 time that it came out of the 10 total dice rolls. We're going to do it again with 2. I have 1, 2 here. 2 or 2 out of 10. Now you're going to be doing it yourself with your own experiment. So don't just copy mine because it's easy. Please try it out yourself. Now let's say you didn't have a 3, right, that came up. You could still have 0 or 0 out of 10. That is okay because we're doing these experiments. So my 3 came up 1 or 1 out of 10. And then let's see, 4 came up 1, 2, 3. And my 5 came up 1 out of 10. And 6, 1, 2. 2, 0.1, 0.3, 0.1, 0.2, 0.1. Okay. So what we have here is called your relative frequency distribution. So that's this whole table that we've created. Now, if we're just looking at one of these, this would be called your relative frequency. So when you combine it all, it's just the collection of all of these distributions. So let's have you try it one more time. So pause the video, see if you can do example 1. It says the following chart shows the results of a survey of bid prices for 50 paintings on eBay. Consider the experiment in which a painting is chosen with a bid price and is observed. Find the relative frequency distribution. So 0 to 9.99. So this bid price had 6 occur. Within this price, it had 23, and so forth as it's coming out. Now, in order to get your relative frequency, right, how many total paintings do you have? Well, we have 50 paintings. So of our 6 paintings in this category, we're going to divide it by 50. Doing it again, we have 23 in this next category, 23 out of the total 50. And again, 15 out of the total 50. And one more time, 6 out of the total 50. So this would be your relative frequency distribution table. Now what we can do is use it to find certain items. So it says, find the relative frequency that a painting in a survey had a bid price of less than $50. Okay, so if we're talking about less than $50, right? Less than 50, well, that would count as from 10 to 49.99, and again from 0 to 9.99. So we're going to be taking these values here, and there's 2 ways to calculate it. So one method is to add up both of your frequencies. We can do 6 plus 23 all over 50, 29 over 50, which equals 0.58, right? So we can take all of your frequencies, the actual numbers that it actually occurred, and still divide it over the 50. Or you could do method 2, where you actually take your end result from your distribution table, those probabilities, and you actually add them up. So 0.12, 0.46, adding them up will get you to the same exact result. Now, it doesn't matter which one you choose, you just pick a method and you get very, very good at it. All right, let's do another one. It says, find the relative frequency that a painting does not have a bid price of $9.99 or less. Again, we can do this one of two ways. Now, if you haven't paused the video yet, definitely do it right here, right now. So if we're looking for not a bid price of $9.99 or less, we're looking at this one, and this one. So we can go ahead and add those frequencies together. 23 plus 15 plus 6 all over 50, which is 0.88, or method number 2, right? We can add all of those frequencies together, 0.46 plus 0.30 plus 0.12. Now there is a third option. Our third option is to negate the fact. Now, in order to understand this one, we have to understand some properties of probability. Now, are we able to have a negative probability? No, we cannot have something that is in negative. The lowest we can have is 0. So if the lowest we can have is 0, what's the highest probability we can have? Because keep in mind, these are percentages. This is 12%, this is 46%, 30%, and again, another 12%. So what's the highest percentage we can have? Well, we can have a total of 100%, which means if we added all of these up, it would total to either 100% or 1. So if we know that fact, then what we can do, instead, we don't want to add these, which it's not a big deal if we add it. This problem isn't huge. In our future, we're going to see values that are really, really big. We have a whole bunch of alternatives. So we can work on negating something that we don't want, right? Think about the complement of E. If this is E, right, your event, and we want to find not E, we're going to subtract your event from the total set of outcomes. Your total set of outcomes is 1 or 100%. So 1 minus 0.12 is 0.88. Highest probability is 1 or 100%. All probability add to 1 or 100%. So to negate, and find not E, or the probability of not E. That's a little bit better to write. Probability of not E. We're we're going to subtract 1 minus. Okay. So let's try it one more time. It says example 2, in a survey of 250 hybrid vehicles sold in the US, 125 were Prius, 30 were Civics, 20 were Camrys, 15 were Escapes, and the rest were other makes. What is the relative frequency that a hybrid vehicle sold in the US was not a Toyota Camry? So we could take the long route of then add. Keep in mind the rest were other makes. So if you don't have 250, you're going to have to figure out how many fit that category. So instead, let's work on that negation that we just worked on from that method 3 from above. Now, if you pause the video and got the right answer, I would definitely go back and rewatch that little spiel. So instead, let's look at Camrys. How many did we say are Camrys? We said 20, right? And I think these are technically in like, oh, no, these are not in thousands. These are just 20 Camrys. So we have Camrys, of which 20 were sold. How many total cars do we have? We have 250. So then how many are not Camrys? Well, to get that negation, right, we're going to take the total amount of cars. We're going to subtract out the Camrys. So 250 minus the 20 is equal to 230. This 230 are all the cars that was in this survey that is not a Camry. So then what is the probability that it's not a Camry? Well, if you have now the probability of not a Camry, we can take your 230 and divide it by 250, or 92%. Again, you could also have added them up, find all of their probabilities, and do exactly as we did from up here. Okay, but just don't be afraid to negate and find the opposite of what we're looking for. And if we're trying to find the probability, just making sure if it's with the frequency first, we still end up dividing. Now, some properties. So it says the relative frequency of each outcome is a number between 0 being the lowest that you can have, again, no negatives, and 1 being the highest, 100% inclusive. So pretty much the probabilities in either the 0, 1, or decimals between. So there should be something that alerts you that if you have a negative, if you have a number over 1, that there is certainly something wrong. You have to be 0, 1, or a small number in between. Now, the relative frequency of all outcomes add up to 1, right? 100%. They all have to add up to 1 in one case or another. So that means all of these right here, if we made a distribution table for this one, that would add up. This would all have to add up to 1 or 100%. All events, probabilities add to 100%. In your experiment, all of these things were experienced. So the relative frequency of an event E is the sum of the relative frequencies in the individual outcomes in E. So pretty much whatever we're looking for as far as your event goes, we're going to be adding up your probability or relative frequencies or your probabilities of which. So things that we did here and again here.